Now let us talk about physical properties of nonmetals. First of all, let us see the examples of nonmetals. They are carbon, sulfur, iodine, oxygen, hydrogen, etc. The first physical property of nonmetals is that the nonmetals are either solids or gases. But there is an exception. What it is? It is bromine. Bromine is a non-metal, which is not a solid, which is not a gas. Bromine is a liquid. Though bromine is a non-metal, it is liquid. So this is an exception. Then the non-metals are not shiny, which means they are non-lustrous. Non-metals do not have luster. The next property is that the non-metals cannot be beaten into thin sheets. That means the non-metals are non-malleable. That is, they cannot be beaten into thin sheets. Also, the non-metals cannot be drawn into thin wires, which means the non-metals are non-ductile. Then, the non-metals are poor conductors of heat. Also, the non-metals are poor conductor of electricity. And non-metals are considered as non-sonorous because non-metals do not produce any ringing sound while striking on hard substances. That is why the non-metals are non-sonorous. So, these physical properties, differences between metals and non-metals, you keep in mind. First of all, that the metals have luster while non-metals do not have luster. Metals are hard, they are solid, but non-metals are gases or it can be solid. And exception is bromine. Metals can be beaten into thin sheets. They are malleable. Non-metals cannot be beaten into thin sheets. That is why they are non-malleable. Metals can be drawn into thin wires, whereas non-metals cannot be drawn into thin wires. That is, they are non-ductile. Metals are good conductors of heat, whereas non-metals are poor conductors of heat. Metals are good conductors of electricity, whereas non-metals are poor conductors of electricity. Metals produce ringing sound while striking on hard substances. That is, they are sonorous, while non-metals are non-sonorous. Now, all the properties which we discussed for metals and non-metals, there are many exceptions. So let us now see what are the exceptions. First exception, all metals except mercury exist as solid at room temperature. You can see this is mercury. We have learned that all metals are solid at room temperature. There is an exception which is mercury. Mercury is a liquid at room temperature. So this is mercury. We have also learned that the metals have high melting points. right? But there are exceptions. Gallium and cesium have very low melting points. You can see in the image gallium and cesium. These two metals will melt if you keep them on your palm. So these two are exceptions, that these two have very low melting point, although they are metals. Another exception is that the iodine is a non-metal but it is lustrous. We learned that non-metals are non-lustrous, but it is an exception that iodine is lustrous. Next is that carbon is a non-matter that can exist in different forms. Each form is called an allotrope. So, what is the meaning of allotrope? Allotrope is that the different forms. So, when we talk about allotropes of carbon, we are talking about different forms of carbon. We know that diamond is an allotrope of carbon, right? So diamond, an allotrope of carbon, is the hardest natural substance known, and it has a very high melting and boiling point. So remember this, that diamond, which is an allotrope of carbon, is the hardest natural substance known, and it has very high and high melting and boiling points both. Graphite, which is another allotrope of carbon, is a conductor of electricity. So what are the allotropes of carbon? Diamond and graphite, which means they are different forms of carbon. The alkaline metals. Now we are talking about metals. Lithium, sodium, and potassium. They are so soft that they can be cut with a knife. We have learned that the metals are hard, right? But what is an exception? Here, for exception, we have three metals: lithium, sodium, and potassium. They are so soft that they can be cut with a knife. They have low melting points. So, this is about the exceptions in physical properties of metals and nonmetals. I hope you have understood it. Thank you.